Yes, I can see it now.
Okay, perfect. Okay. So once you have a part that's either modeled in SolidWorks or if you import a file into SolidWorks, as long as it's say in a solid format, you can program toolpaths with it for Visual CAM. You can even do like 2-axis operations or 2.5-axis operations just by selecting sketches from within a part, or we can also work inside assemblies for programming parts in Visual CAM for SolidWorks. So we do run inside part and assemblies. Now, typically, the workflow here is you would go into your machining browser, which automatically appears when the plugin is loaded. You'll also notice that there's a tab for Visual CAM 2019 that appears in your command manager. And you can always go between your feature manager design tree and the Visual CAM tab by just single click of a button here. So there's two browser windows. The one on the top half is called the machining browser, also known as the machining operations browser. And the one in the lower half is called the machining objects browser, which gives you access to defining tools or loading tools from libraries, saving tool libraries, machining regions. You can create, extract machining features, and also use knowledge bases that are created from other parts that you had programmed earlier. The Program tab has two main tabs, Program and Simulate, and we work our way from left to right as we work through these groups in here. So the typical process here is the first thing is we want to establish the coordinate system orientation for machining. So if you take a look at this part here, your blue arrow represents the z-axis, and then the red is the x, y, the green arrow represents the y-axis. So the way the part is currently oriented here, you would be milling features that is normal to this particular face. That's how the z-axis is pointing, right? So you typically want to either mill from this orientation here, the surface that I've selected, so the Z tool coming down from that axis, or you may want to machine the bottom side first, depending on whichever side you want to program first. Am I making sense?
Yep.
Okay. So the workflow here is, first step is to going into the machine tool setup. And as I pointed out, by default, it's in the same orientation as the machine coordinate system, is same as the world coordinate system. So we want to change that. So rather than having to go and redefine the part or change the sketch plane and remodel the part, the easier way to do it is just basically rotate the coordinate system in here. So you can use the controls that are built in here, or you can say select a surface. I can pick a face, and it'll derive the normals based on the surface. So you'll now notice that the z-axis is now pointing up, which is normal to the surface. And you can also determine the x and the y. So currently, the x will be parallel to the shorter edge, and the y would be parallel to the longer edge. If you need to flip the x and the y, or if you want to put the x parallel to this edge and y, you can rotate about the z-axis in here, and that automatically reorients the coordinate system for machining.
Okay.
Do you have any questions on that?
Nope.
Okay. In the next step, we'll define the number of axes. So for 2 and 3 axis programming, you would pick 3 axes. 4 and 5 axis options are available in higher configurations, starting with Expert, Pro, and Premium. 4 axis is available, 5 axis is available in Pro and Premium. And in the next step, we want to pick the post processor. This would be the machine tool that you'd like to output the code for. Do you happen to have the information for that?
It's the FNUC 21.
FANUC 21. Okay, so we currently have several different posts for FANUC here. We have one for 21I, 21M. We have different variations of the FANUC post in here, and we can always customize each of these posts to, output the code that's similar to what your machine is expecting here. So I'll go ahead and pick the 21M. Would that be okay for the demonstration?
Yeah. Yep.
Okay. And you can always use edit in here to go ahead and customize the post processor to make changes as needed. So the post generator comes included with the software, so we can help you make the changes, or you could even modify the post as well. In the next step, we want to go ahead and define the stock material. So we go to stock. With the standard configuration, you can define the stock as box and cylinder. So I'm going to go in and define the stock as box. I'll select the ignore wireframe, so it'll automatically exclude any of the sketch geometries that are consumed or unconsumed in your design process. And when I select copy model box, it'll compute the minimum stock extents that's required to machine this part. Do you happen to have a preference on the stock size that you'd like to go with for the purpose of demo here?
I forget what this part dimensions is, but I would say leave like 50 thousandths all around.
All around in X and Y? Okay, we can do that. And then how about the height or the thickness?
Um,
You can go
let's do the
750.75. Okay. So I'll change it to 0.75, and then I'm going to add
Yep.
50 thousandths on each side, so that'll be 100 thousandths in total. So I can do that right here.
Actually, okay, so it gave you the. Let's just put it at 3.25 for your length, and then 1.75 for the width. That'll
Okay.
yeah, gives
We'll
us
do
some
Okay. And then we have
sizes.
3/4 inch thick for the stock. So we've defined the stock in here. I can display the stock. The next step is to align it. We can have the stock flush to the top in the Z, or we can have it centered in a Z, so it leaves material both on the top face and the bottom face. If I go into one of the end views, you'll actually see it. So you'll notice that there's material being left on the top as well as being left on the bottom. If you do center,
Yep.
if you pick bottom, then the bottom of the stock is flushed with the bottom of the part from the orientation that you define. So you can do top, center, or bottom. So depending on, if you want to remove material from both sides or just one side. Okay?
Okay. Yeah. Yep.
So since this part requires machining from two sides, and if the stock needs to be faced from both the sides, I would put it right in the center.
Okay.
Okay. So once we have the stock aligned, we can then define the work zero. This would be the location of your XYZ origin or the workpiece origin. It's also called as a work coordinate offset. Could be like a fixture offset location in G54. So this could be defined to the top of the stock material, or you can put it to the center or to the bottom, lowest point. So I'm going to do higher Z, and then you can pick a location here. You can do a southwest or center, whatever you prefer location to establish your 000. So this would be where you place them in a workpiece and then bring the tool to touchdown to establish your G54, your work coordinate offset.
Yep. Nope. That looks fine to me.
And then we can also select the work offset, and if you want to output a G54, you can specify 54, and then the prefix will be added in the posted output file. So there's the location of a work coordinate origin. In the next step, we are ready to program toolpaths in here. So the first step would be to program like a facing operation to basically face it down to the finished height of the part. We would do that by going into two axis and facing. And with our 2019 version, we will automatically take into account the silhouette of the stock material, so you don't have to pick any features for facings. It'll look at the silhouette of the stock. All you have to do is grab a tool for it. So I could use like a face mill cutter, or just to use an end mill, like a 3/4 inch end mill, set feet and speeds, clearance, specify the conditions for your facing operation. You can go like a linear cut pattern or an offset pattern, and selecting generate will automatically generate the toolpath by taking into account the stock silhouette, and you'll see that a facing operation is generated.
Yeah.
So we'll go into the Simulate tab and select Play to run a verification. Do you have any questions so far?
On this facing operation, does it step over with a tool still in contact with the part, or can you do a facing operation that the tool path clears the part completely and then comes in the steps over and comes back, so you don't have any the tool's not cutting while it's stepping over?
Okay, so you would either have to extend the stock, kind of basically have it go past it. So right now it's stepping over to the extent of the stock. Or if you choose just to do a climb cut, then it'll be just cutting in one direction, and you can do an entry and exit to extend past it. So if you wanted to extend past by a certain amount, then you can define a sketch to go overshoot it by that amount.
Okay.
So I could go back into the Program tab. I could create a sketch in here, and I can go normal to the view, and I can draw a sketch that'll extend out by a certain amount here. So I could draw a sketch right in here And you just want to step over on one of the sides, right? Is that correct? Just over in the direction you're cutting.
Like both sides, so your step over isn't cutting. It's not cutting while you're doing the step over.
Okay, all right, makes sense. So I'm going to go ahead and put in a distance in here. Maybe I could say this could be 1/2 inch, and I could do the same thing over here. Right, and I'll basically put these two sides to be coincident in here. I can use all the SolidWorks relationships that you have, and you can use the you can add a relationship and make these two coincident, or you can say this could be like a 100 thousandths from this edge. Okay, so now I'll go ahead and exit the sketch. So on the facing operation now, I can just pick the sketch as my drive geometry, generate the toolpath. Okay, so I can basically select this sketch as my machining geometry for programming the toolpath.
Okay.
So go back into facing and then pick that sketch as a region for it. Would that help?
Yep.
Okay.
No, it's one of those things that comes up every once in a while. I do produce some parts that are left as a machine finish, and the end customer, they like it to have that visual machine marks left in there. So I know if there's like step over, they might not like that, but they do like those lines.
Okay.
So
yeah, so you can basically define a sketch and then use that as your boundary for facing operation.
Okay.
Yeah, or if you do not pick a sketch and generate the toolpath, it's only going to use the silhouette of the part like I just showed you right here. So there's two ways to accomplish that.
Okay.
So either you can define a sketch to extend it, or just basically pick the silhouette. All right, so once you're through with the facing, in the next step, you would probably want to go ahead and program some of these features in here, right? You have some slots, you have some pockets, holes that you want to do. So these features, we could probably use a slot machining. So you have a radius of 0.125. So if you want to use a 1/4 inch tool, you can do a slot machining on this here. So we could do 2-axis slotting or slot machining operation. I can right click and say select loop. I can pick the loop for this one here and do the same thing over here as well. So I just click on select curve edge regions and right click and do a select loop or select tangency to pick them. So you can take advantage of all your selection tools in SolidWorks. You can specify a tool for it. In the slot parameters, you can choose to determine close and open automatically. If you want to add a cleanup pass, if you're using a smaller tool, you can do that as well. In the cut levels, you can actually get the depth of the model. That's an 1/8 inch deep, and then generate. So that'll create a slotting operation. It's just doing one pass as you see it.
Mm-hmm.
And if you want to go in multiple levels, you can basically split this into multiple levels in the cut levels. Split it in half, so it'll give us 2 Z levels.
Okay.
Now if I change the tool in here, so let's say I go from a 1/4 inch to an 1/8 inch, and then regenerate the path, you'll notice that it does a high-speed cut pattern or like a tricardial cut pattern for the pocketing operation.
Okay.
So if it's equal to the cutter diameter is equal to the width of the slot, it'll just do one pass in the center line. But if it's if the cutter diameter is smaller than the slot width, then you'll get a high-speed cut pattern. And you can add a finish pass around it to clean it up as well.
Okay, that was going to be my next question then.
Yep. You could either do it on the same part of the slotting operation, there's a cleanup pass, or you could add a profile operation. Once you're through with the slotting, you can go ahead and introduce a profiling operation to go back and finish this up if you want to use a separate operation for it. So there is an option in the slotting operation to also use a cleanup pass, or you can add a separate operation in here to basically choose whether you want to climb cut, and then you can put in the depth in here go to cut levels, set the depth, and then specify your entry and exit parameters, how you want the cutter to lead in and lead out. And in the cut levels, that's where the depth goes in. So we have a finished pass. So I can leave stock and then go back and clean it up. And you can apply different colors for each operation that you're programming in here. In the simulation, you can either apply them based on a tool or based on the operation. I could go to properties and then pick a color for each operation that's being programmed. So the next step, you want to do these holes in here, and then you want to go ahead and do the chamfers, right, or countersunk using different operations. And then do a profile cut around the periphery. You can do it from this side, or you can flip it over, machine it, and then cut the profiles as well. So here I can check the diameter of the holes. So this one is 0.26. Are these two the same size holes?
Yes.
Yep. So you're going to do a drill and a tap on these?
Correct.
Okay. So you could go to hole machining, drilling, and then you can select drill points or circles. I could just go pick these two edges right here. And then pick a tool. I could go with a 1/4-inch drill bit. Then in the cutting parameters, I can specify the depth. All I have to do is pick the top face, the bottom. And I can select add the tooltip to drill depth. Or I could even say start at 0 and then go down to a depth of 3/4 of an inch. And I can choose a type of drill. I could do a deep drill, countersunk, brake chip, and generate. So that gets your drilling operation. So that's doing a deep drill or a peck drill operation.
Okay.
It goes all the way through. If you want to do a spot drill before deep drill, you can do a standard drill operation, the same one. You can do a copy paste and maybe go like 50,000 deep or whatever you want to program it. And once you're through with the drilling, you want to tap them. Is that going to be like a 1/4-20 tap? You can pick tapping. And again, select the same features in here. And then specify a tool for it. So I can insert a tapping tool, put in the diameter, pitch, thread pitch. I can call it tap 1/4-20. I can set my RPM in here. And then the feed rate will be computed based on the pitch and RPM.
Okay.
So I can specify the cutting depth. And I can choose where I want this to begin the tap and how deep I want to cut it. Go from here down to this point, and then generate it. So I'll put a tap cycle on it. Now, before the tap, you want to do a countersunk in here. You can figure out what the countersunk diameter here is. This is going to be 0.36. So I can make a copy of this deep drill operation. And then I can change this from deep drill to countersunk, and then specify the countersunk diameter in here as 0.36. Generate it. So that'll produce a countersunk toolpath. And you can change the tool that's appropriate for, or if you wanted to program this as a chamfer, you could do this as a 2-axis chamfer operation in here. If you don't have a countersunk tool, you want to use like a chamfer bit to do it. So the same process would apply for these smaller holes as well. So I'm going to skip the, programming of these two in here because the workflow would be very similar. And one of the nice things you could do here is take these 3 operations that you did. This could be the countersunk drill. So you can take these 3 operations and place it in a group called machining operation set. So when you have holes of the same size, you can just load this from a knowledge base, and all you have to do is just pick or identify the machining regions for it.
Okay, so the same geometry, you just pick the location of where you're putting that.
Yep.
Block
you double click and just say select drill points and circles and just pick those areas.
Okay.
Now the entire workflow can also be saved to a knowledge base, and the knowledge base feature is available right from our standard configuration. Now, as this part has programming required from multiple orientations, once you program the first orientation, you typically want to take a look at the estimated time, how long it's going to take to cut it based on the parameters, feet and speeds that you put in, and then post-process this out to your machine tool. Right-click and post, and there's your posted output file. You can define the program number in the work zero operation, and it'll output the program number right at the start of the program as well. So we are outputting in inches. It's moving to the home position, calling out your tool. Your spindle is being set, and there's your coordinate moves. It also calls for a tool change when you have a tool change involved in the program. So you can see it goes from 2 to tool number 11 right here, and towards the end.
Now, let me ask you this, since you brought up the tool change, that my machine does not have automatic tool change. So when a change of tool is required, is there something that can be programmed in that the machine goes and stops for the, because we'll manually have to change the tool out, or is that, do we have to break it up every time we need a tool change? We just have that block of that program, and then we run until we need a tool change and load up the next program.
Okay, well, there's two ways to do it. You can post all operations into one NC file like we just did here. And when the controller sees a new tool being called, typically it would pause the machine and prompt the operator to load the tool. So if you want to have an additional instruction being added, like for example, we can say output an M01, which is like an optional stop before a tool change. We can insert that into the tool change macro in the post processor. So before the tool is called, it'll go ahead and output an M01 or M02, which is like an optional stop or a program stop. So once you change the tool, you re-zero it, then you can go back and continue running the program.
Okay.
So that's typically how most of our users do it. They post it all in one file. Or you could select operations. And for example, in here, I have these two operations that can be grouped into a machining operation set like we did. And then we can post the operations to one output file based on the tool. So you can post operations individually, or you can use the control and the shift or control or shift to select multi-select operations to post it. So there's multiple ways of doing it. And we also have an option to specify a tool change point in the machine setup dialog in here. So if you want to move the tool to a specific XYZ location, so it makes it easier for the operator to swap the tools out, we can output this coordinate location in the post. So before a tool change, it'll go to the point and then stop it, and the operator can swap the tool out.
Yep, perfect.
So we can also configure the post to output this information. So typically with the standard configuration, you can program this part from one orientation, and then you save this part out. You'd have to save a copy of this part under a different name, and then go back and define a new coordinate system orientation by modifying this to point it to the one of the other sites. So with our Pro configuration, we have an added feature called 3+2 machining, which allows you to basically create multiple or additional setups. So I can go ahead and select a new setup in here, and I can specify the orientation. So in this particular step, I would like to do the bottom side, or maybe I can do these holes in here, right? I can probably program these holes before I get to the bottom. So I can say select the surface. I can pick that face, accept it. So you'll now notice that the coordinate system is reoriented. So you now have a new setup. You can have a new work zero defined in here. You can choose where you want to put the 0 to, set to stock, high Z, southwest. So you can place your XYZ origin in here, and now you can program these holes.
Okay.
So you can create multiple setups for each orientation, and you can program these holes if you need to drill and basically countersink them or chamfer these holes. You could program it. So I can add a drilling operation in here. I could even copy and paste one of these drill operations to a copy. And I'm going to paste them right here. And I'll double click to modify it. And I'll go pick these two hole features, accept it. And let me determine the diameter is 0.15. So I'm just going to go grab a 1/8 inch drill bit. And then we'll specify the depth in here. So to cut from the top edge right here to go down to this point, and then I said add tooltip to drill depth. So whatever the taper is, it'll go down to this point right here. Or I could clear this checkbox and just pick this point edge and the point down below here to establish the total depth to generate it.
Okay.
So we have a tool path in here. So I'm going to simulate through this here, and then we'll select and simulate these operations. You can also see the simulation from multiple orientations as well. Okay?
Mm-hmm.
And now I can go ahead and program the bottom side. Add a new setup in here. I could even just do a rotate about 90 degrees on the x-axis. And then insert a work 0. Now this could be a G54 or 55 or whatever orientation that you want to pick. You can change this to a 55 if you'd like to. And then we'll go ahead and add a facing. So I can actually copy this facing operation from the top of the part, paste it down below here, and then right click and then regenerate. So we now have a facing for the bottom side. So it uses the stock silhouette from the other side. And then we could program these features in here. So these are like open pockets that you have on the model, right?
Correct.
And there's a couple of ways how we could do it. We have a method called 2-axis and roughing. We can use that to clear the material around this here. So I can use 2-axis roughing. And I can just pick these boundaries here. I could do a select loop. I'm going to do the same over here as well. And I'll grab this loop here. So I have these selected in here as loops. Now in the cutting parameters, I can pick a tool. I'll go with a 1/4 inch tool. You could specify to use a facing cut pattern for core regions. The cutter will enter in from the outside, work its way towards the part. I can insert a cleanup pass. In the cut levels, I could say I only want to go down right up to this point right here. And I can control the step downs, engage in retract, and then pick generate. So you'll notice that it automatically clears the material out right there.
Okay. Now, yeah, I'm sorry. Okay, I see the tool path.
So it's entering from the outside and working its way in towards the part. Like a facing cut pattern.
Okay. Now, with the through holes that are on the inside of those two through slots, does that tool path actually cut in and follow that profile, even though that was put on in our other setup operation?
Yeah, it will. The tool path will try to follow around this contour in here, right here.
Uh-huh. So
unless you suppress this feature, but if the tool is too big, you'll see that the cutter cannot get in there. So it's not going to gouge the part or violate the geometry, but the cutter will try to get in if it's able to.
Okay.
So if you want to avoid it, there's two ways. One is you either suppress this feature and then generate this tool path, or you can put a sketch around it here, which excludes this feature.
Okay. Now,
sorry, go ahead, sir.
I was going to say you can suppress a feature in a setup and it won't affect your other setups then.
Well, it'll affect the entire part. You got to do a suppress and an unsuppress. So in this particular case, since we have not programmed this hole in the other operation in here, I could do a suppress, or I can just do a new sketch by just connecting these two endpoints.
Okay.
So when we do a 2-axis operation, it can be generated based on a sketch and not just a 3D model. So that might be another way to go about it. Okay?
Yep.
And then you can follow it up with a profiling operation to clean this up. So we can add a sketch in here to use this for a profile cut. Or we can, if you don't want it to get into this area right here.
Okay.
And then finally, you want to do this like a counterboard that you have here. You want to probably pocket this out since it's already drilled. So you can do a 2-axis hole profiling or a hole pocketing operation in here. This is about 0.44, so you can probably go with a 3/8 or a 1/4 inch cutter. And we can use a 2-axis hole pocketing. Just pick this feature right in here. Go grab a tool. I could use a 1/4 inch tool. In the cutting parameters, we'll just grab the depth. We'll add one cleanup pass at the bottom. And there's the helical cut path. And you can control and adjust the helical parameters in here. So that gives you a helical toolpath. So this is one of the ways how we can go about programming it. We can have each setups output separately to an NC file. Now, one of the other features we've also introduced is called what's called feature-based machining, which is available right from our standard configuration. So in this particular case, what you noticed was we had to select the features and machine it, right? So we had to pick like a pocket feature. We had to select chains, select loops using these techniques. Now, with the feature-based machining, we can automatically detect features. So when we go into the Features tab and click on Automatic Feature Detection, it's going to analyze your entire part and identify features from multiple orientations. So here we have the first orientation, we have the second orientation, orientation number 3, and orientation number 4. So if you look at the first orientation, it identified a silhouette feature, which is basically the silhouette around the entire part that you're looking at right there.
Mm-hmm.
And then we have the planar face identifies, and then you have the 2 prismatic pockets and identifies the hole features. So there's 2 types of holes. And then we have the chamfer features in here as well. So once you identify the features, you can just select this and then generate a toolpath. You can do automatic feature machining. So it'll generate the toolpath for each of the features. And then you can go back and change the depth or any of the parameters as necessary.
Okay.
So I can select, so let me go ahead and create a feature-based machining operation in here. I'll add a new setup in here, and I'll just put it back to the machine coordinate system orientation. And I'll just insert a work 0 for that as well. So now I'll create a automatic feature machining. Okay, so here it's erroring out with saying cannot find valid data. It's possible that the tool what I used was way too small or way too big for it. So I can go back and change the tool in here for the pocket operation. I can change this to like a 1/4 inch or 1/8 inch tool and go back and regenerate. Okay. So I can see it's generating the toolpath based on the features. The same thing applies to the profile as well. I probably picked a tool which is in the default library was very large. And for the whole features, you'll notice that it displays the whole feature cross-section. It has information about the diameter and then the depth, all the parameters in here. You can pick the tool that's appropriate for it. So we also have a filtered list. So we'll find a tool that will match the diameter of the hole or equal to or less than, or you can go to the full list to pick a tool from the list. So the filtered list will give you the choices to pick a tool that's equal to or less than the diameter of the hole. So you can notice that there's a 0.362. I can pick a 1/4 inch drill bit. So that's how you can use feature-based machining, and you can program it from all the different orientations. With the pro configuration, it can identify for each of the orientations. In the standard, it'll identify for the orientation that you defined the machine tool coordinate system for, which is normal to the face that you picked.
Okay.
So again, for orientation number 4, you see the different planar faces. It also identifies the pockets and the hole features. So if you want to exclude some of these, you can just select them and hit delete. Since they're already machined from the other side, you can delete those features out as well. So we can identify different types of features like holes, pockets, prismatic features like closed pockets, open pockets, boss features. So different feature types can be identified. And finally, you want to do a profile operation in here. For the first side, I can just select the silhouette feature, right-click and choose profiling. You can also interactively select the features, and you can program it. So I have the tool selected in here. In the cut levels, you can see the total depth is determined, depth per cut, and then generate will program the toolpath. So you can do a combination of both feature-based and also, by picking features from the model like face edges or sketches to program your toolpaths.
Okay.
Would there be any other questions on the demo I can assist you with?
For that final profile path, and this is just a general question too, your entry and exit points of the tool, can you change that to a different side of the part if you need it to be?
Absolutely. So I use the feature-based machining so that it automatically determines the entry and exit location. But if I'd like to specify a certain specific location for entry and exit, I will show you how to do that in here in just a moment. So I'm going to go ahead and select a new profiling operation, or I can just do a copy and a paste of one of the existing operations in here. So I'll just do a copy paste, and then I'm going to place this after the drill operations. I'll double click to edit. I'm going to remove these all and then do a save. Now I can go to my machining regions and I can create what is called a surface edge region. And I'll just right click on this and select tangency or select loop to accept the selections. So now what you're noticing here is basically it created a machining region and displays a start point and a direction arrow. So since you cannot change a start point of a sketch or a face edge in SolidWorks, we've introduced this machining regions method where you can actually select the start point. So I can click on a point, then I can drag the start point anywhere I want to along the sketch. So for example, I want to put it right in here. So I'm going to click over there, and then you'll notice that the start point is now changed. I'll accept the change. So now going back to the profiling, I'll choose predefined and just select this predefined machining region. We'll grab the tool for it. In the cut levels, in the cut parameters, you can choose the cut direction. Cut levels, you can specify the total depth in here. So going from the top all the way through to the bottom. Or you could even say you want to start at 0, and then you want to go 3/4 of an inch. And you can break this up into multiple steps, like 1/8 inch or 1/4 inch or whatever step increments that you want to go. And set your entry and exit, the type of entry and exit you want to apply. And you can also have an overlap distance to overshoot it so you don't have a witness mark being left over there. And so now when you generate it, it's going to create the toolpath and apply the entry and exit where you chose, as long as you do not select this checkbox to use the midpoint of the longest side. So when you clear this checkbox, it'll use the start point. If you have this selected, it'll use the midpoint of the longest edge. So here, after I changed it, it's entering and exiting over there in the back of the part or wherever you pick this entry and exit location. And you can change your entry and exit parameters in here, how you want the cutter to lead in and lead out. And with an overlap distance. So now if I run a simulation in here, so that's how we go about doing it.
Okay. Now, one final question. What about instancing a part? So say I have a setup and I want to cut multiple parts from one sheet or one block.
So basically the origin is going to be the same, but you want to do multiples of the same part. Is that correct?
Yep.
Okay. So the easiest way for you to do is we have a option called XY instancing. So this feature comes as part of our Pro configuration, which is part of the 3+2 module. So you can select XY instancing, and you can specify a spacing between each part. So for example, I could say I want to have it place it apart by 4 inches in X and maybe 2 inches in Y. So I can put in the spacing in X as 4 and Y as maybe 2. Then I can say how many additional copies in X. I could say I want to have 3 more copies in X and then 1 additional set in the Y. So it basically does 4 copies in X and then takes the 4 copies and then instances on the Y as well. So you can specify the X and the Y spacing. You generate it. Now the instance is generated. You can basically place the operation in the instance folder. So now when you select this operation here, you'll see it's creating multiple instances. You can edit the instance spacing as well. So you can instance it based on the part priority, or if you want to do it based on a tool priority. So if you do part priority, all the operations will be programmed on one part before it goes to the next one. If you do it based on tool priority, so you'll minimize the number of times you got to change tools because you want to run all the, use the same tool to run it on all the parts and then go back and, run it with the next tool, right?
Yeah.
So you can have one instance folder for each tool that you're using.
For each, okay.
Yeah, so I can repeat the same here. I'll make a copy and a paste of the instance, and then I can just move the slot machining operation into it here. And also I can have the profiling since these two are using the same tool.
Okay.
And you can also simulate the instances as well.
And you said that's only available on the Pro level?
It's part of what's called a 3+2 module, which is included in the Pro, the 3+2 module. So it's not just in the standard. So, you can talk to our sales and they'll let you know, what are the options that are available to get those, options of multiple setups and being able to do the instancing.
Okay.
And now when I post this operation in here, right-click and do a post, and you'll see that it outputs each of those instances in here. So they're all output right in here. And I can enable the comments to be output in the post. I can say output comments. When I go back and repost it, it'll output the instance numbers for each operation. So you can see instance number 1. I can do a search for the next instance. So you can see the instance number 1 for the slotting, and then the profiling. It goes to instance number 2 for the slotting, instance number 2 for the profiling. So it automatically repeats itself.
Okay.
And computes the coordinates based on the instance spacing. Would there be any other questions on the demo I can assist you with?
Nope. I think that answered my main questions. My main was especially the instance, because that's something that I definitely foresee on using in the future.
Okay.
So, and if the standard does not allow for a 4th axis, correct? The standard version?
That is correct. The expert version is the minimum that you would need to start for 4 axis. Do you have a rotary table on the machine?
No, not yet.
Okay.
But it was something that in the future that we'd like to have.
Would you be looking to do a continuous rotation, or would you be looking for more of an indexed where you rotate it, lock it into a specific orientation to program? So, for example, if you consider this part to be set up on a 4th axis, you could do 0, maybe 90, 180. Would that be how you would programming it, like indexing it, or would you want to be able to do like a continuous 4-axis machining?
No, for the immediate need would just be indexing. So,
okay.
Yeah. So we'd probably just use a manual table.
Okay.
But I would like to in the future have that rotary 4th axis. But I think before we jump into that, we'll get our feet wet with just the 3-axis here.
Okay. Yeah. All right. So would there be any other technical questions I can help you here?
Nope. I think that's all I can think of right now.
Okay. Give me just a moment here. So I'm going to go ahead and pause this recording.